now have some time left to some questions, to answer some questions if you have some. There was a question from Benjamin Bouvier. Maybe Maxime, you can answer, or about the question if there is that much noise in the radial wind speeds. So
Yes.
I guess he means in the along the beam.
The work.
Yeah.
Yes, along the beam. I've done the work in the last version of the papers. For me, it's not negligible. For the commercial LiDAR, on average, the variance of the noise is 5% of the total variance measured by the LiDAR. And from the prototype LiDAR is a sampling rate multiplied by 4. This is 7%. So there is much noise because this is due to the increased sampling rate, which leads to higher noise. But I think it's not a big deal because we can identify it properly and we move it. But 5% or 7%, I think it is not negligible. It should be identified and removed.
And this is done in your case through the spectral analysis.
Yes, both on ground-based, on floating, we are removing the noise.
Then I don't think we have many more questions in the chat.
You have one more, I think, Ned.
I don't see really. We have a comment from Claudine Charondière about this the Wakeful project at Nantes. Thank you, Claudine. We will have a look and maybe try to make some connections.
Yeah, but this is an interesting project because I think at the end, motion compensation algorithm should involve compensation of the mechanics of the buoy and compensation based on post-processing of the data. Because for both methods, the geometrical and the spectral approach that we proposed, what we saw now, it is that the performance of the method is, I would say, not that good, it's not the proper word, but the method performed less for higher tilt. So it could be interesting to compensate the tilt of the buoy and also maybe limit as a maximum and do propose a buoy, not a compensation mechanism, or maybe a buoy that limits the motion along the axis, limits the translation actually. I think it is a perspective for improving as well our method, limits the translation and limits the tilt. And combining both could be the solution actually.
I think at some point in Nantes, they did that of putting a compensation system. I think it was with a scanning LiDAR a few years ago.
Yeah, I remember. I've seen that.
Yeah.
Yeah, I think the solution is both. We need both a compensation mechanism and an algorithm to solve the problem, I think.
We have another question from Akio Hansen. Is it also planned to compare different LES model for the sites? For example, Palm LES within the NEMO project. Maybe you can answer, Maxime, or Julia, as you want.
I can also. So it is not so. It's a German question. So PALM is normally the model that is used by our colleagues at EVIS and Oldenburg, and they are involved with the mesoscale modeling in this project. They will not run LAS themselves for this project. In principle, we could do it, but at the moment, it's not planned to benchmark different LAS approaches. So unfortunately, no. But I think it could be a future thing to do this.
Thank you, Julia. We also have a question from Emmeline. Hello, Emmeline. About the database measurement that we acquired on the Île du Planier. Emmeline asked if the database is available online. Maxime, you can answer that question.
It should be on DRACCAR, our website, but we have shared this. But it is not public actually. We share this with the partner of the project, but let's see. I don't know, Neil, what we can do, Neil, what we can do exactly with the dataset. If we're interested in this, we can.
There is always a way to acquire the data. So just take contact with us and we will see how we can arrange that.
Mm-hmm.
But as you mentioned, Maxime, I think the metadata should be available on our website.